Hello students, how are you? In today's lecture, we will discuss about the second order infinitesimals and we will derive the least invariance condition for the second order ordinary differential equation. Students, if we want to see the invariance of a second order differential equation, then we have to write it down in a bar form like d2y bar by dx bar 2. And you can also write it as like d by dx bar into dy bar by dx bar. Now by using the chain rule, you can write it as dy by dx into dy bar by dx bar as it is divided by dx bar over dx. Okay, actually they should write first like d by dx into dy bar by dx bar and multiply by dx is divided by dx bar, because after simplification you can recover the previous step, but they have written it in the denominator, so it actually means that if you multiply it, then definitely it will get reversed. Okay, now students, d by dx as it is, and the value of dy bar by dx bar that I have derived in the previous lecture, and it is actually equal to this one. Okay, so I have written down dy by dx plus dx of capital Y minus dx of x into y prime epsilon plus order of epsilon square, and that is divided by dx bar by dx. Students, the value of x bar is actually equal to x plus epsilon capital X of xy plus order of epsilon square, and if you want to take its derivative, like if you want to find dx bar by dx, then you will get dx by dx. And in the similar way, you will take the partial derivative of capital X with respect to x, and then total derivative with respect to x. Similar way, partial derivative of x with respect to y, and then dy by dx. Okay, plus order of epsilon square as it is. Now this is actually equal to 1, and here you will get the value of the operator, that is dx of capital X plus order of epsilon square. In the similar way, student, that I have defined earlier, that if you take the denominator in the numerator, then its power will become equal to -1, and if you expand it with respect to epsilon, then you will get this value. And if you multiply both of them with each other, and after taking the higher order terms in order of epsilon square, you can write it as like yxx is equal to dx of yx minus y double prime dx of x. That means you just need to compare the values of epsilon on both sides. Means when you substitute this value in the least invariance condition for the second order differential equation. Now here we have defined the extended form of the total differential operator. Like we can write it as dx, that is equal to partial derivative with respect to x plus y prime into partial by partial y plus y double prime. So here it should be y prime, and if here it is y triple prime, then here you have to write partial y double prime, and up to so on. Now students, and expanding yxx gives, students, already I have defined that the value of yxx is actually equal to this one, like it is dx of y of x minus y double prime dx of x. So now I will apply here the total differential operator that is in extended form. Now if I expand it, I will get this term. Okay, now in the coming lecture I will explain that how to expand yxx, but here our task is to define the least invariance condition for the second order differential equation, so I will move toward that. Now students, we can write it as like d2y bar by dx bar 2, that is equal to f of x bar y bar dy bar by dx bar. You know that when we were deriving the least invariance condition for the first order equation, then I have written down there dy bar by dx bar is equal to capital f of x bar y bar, but here we have a second order derivative, so I should write the value of dy bar by dx bar here. Now if I substitute this value that we have defined earlier, the value of d2y bar by dx bar 2, then I will get this term in the left hand side, and similarly the value of the infinitesimal x bar is equal to this one, and the value of the infinitesimal y bar is equal to this, and into dy bar by dx bar, that is equal to this one, that is from the first order least invariance condition. Okay, Now that upon substitution gives d2y bar by dx bar as it is plus epsilon plus order of epsilon square, and if you expand it then you will get this value. Okay, now students, if d2y bar by dx d2y by dx2 is equal to capital F of xy dy by dx, then it will become equal to this one. Now what we are doing here, actually if the given ordinary second order ordinary differential equation is invariant, then definitely this term after simplification should give this value. Okay, and when this value will become equal to this one, when yxx will become equal to this one. Okay, so I have written down yxx is equal to this. Now if we want to find if we want to write it in extended operator like gamma 1, so it will become equal to yxx is equal to gamma 1 of f. Now students, gamma 2 will become equal to actually if you want to write gamma 2, then you have to write gamma 2 is equal to gamma 1, okay, plus yxx into partial by partial y double prime, and they have just substituted the value of gamma 1, that is capital X partial by partial x plus capital Y partial by partial y plus yx partial by partial y prime plus this one. Okay, now students, if we denote our given second order ODE by this one, like delta is equal to y double prime minus, like I have taken all these terms on the left hand side and put it equal to 0, so delta will become equal to this value, and then the least invariance condition for the second order differential equation will become equal to this one, like gamma 2 of delta at delta is equal to 0 is equal to 0. Now students, what is the crux of this lecture? And the main idea is that if you are given the second order ordinary differential equation, or you can say their corresponding infinitesimals too, and if you are asked to find that either the values of the infinitesimals are correct or they satisfy the given equation, then you just need to substitute these values in this equation. And also in the coming lectures we will see that we can use least invariance condition to find the corresponding infinitesimals. Like till now we have just check out the infinitesimals or the Lie group, and we have just verify our given differential equation. But if we are given the differential equation, then we can also use the least invariance condition to find the corresponding infinitesimals. Okay, now this is all about this lecture. Thank you so much.